Hello, Peanut. This is our cat. He is dying of cancer. Look at him die. He's dying very slowly. We tried giving him everything he wants, but the problem is he wants sometimes to just annoy us. He wants to drip slobber all over our hands while we're trying to do things at the computer. Yeah, and if we feed him milk, then the slobber is full of milk. So we feed him milk at night and clock him downstairs with the milk. I don't know. Maybe he just wants pets. Do you just want pets, Cancer Cat? Is that what you want? Lots of pets? You want to be on camera and getting lots of pets? You want to be kind of half on camera and getting lots of pets? Is that what you want? You want to sit in the biggest space that we have because we've set aside the space for filming. And you want a space.
But you don't have a space.
So here I have a Raspberry Pi that a friend of mine gave me for free. I was looking for a Pi Zero. I think a Pi Zero would have done everything I needed, but this is what they had. It's a Pi B+, Pi 3 B+. And it's in a case which they 3D printed, and it glows in the dark. So the question is, how does one open this case? I think you just push here. Yeah, there we go. Alrighty, it's a Raspberry Pi 3. So the next thing we need to do is make sure it works. So let's hook some things up to it. I plan to put it in this keyboard. So let's hook this keyboard up to it. This has a smart card terminal on this keyboard, and that I think is maybe about the right size for this. Huh? You think? What do you think? I don't know. Okay, so yeah, we're going to hook this keyboard up to it. We're going to hook a monitor up to it. We need to hook some power up to it and see if it does a thing. It's a little bent there, but that one works. Cool. Ooh, lights came on. Cool. Well, we're not getting an HDMI signal. Let's try repowering it with the monitor hooked up. We're also not getting numlock, caps lock, scroll lock. Now, I don't really know what a Raspberry Pi does if the stuff on the SD card is bad, for instance. I also don't know if, like, some of the ports are dedicated keyboard ports. No, not working. Red light and green light, don't know what that means. Well, I guess we need to check and see what's on the SD card. Okay, I'm back. Wow, that was weird. So on this SD card it was convinced that there was one 124 meg partition that took up the entire drive, even though it's 16 gig drive. Don't know, it was some kind of recovery partition, but it seemed to maybe be recovery for a RISC-based operating system. But I don't know what you'd be recovering if it's the only thing in the... Anyway, so I had to delete the partition, and then when I reinserted the disk, it recognized all 16 gigs of it, and then I run the program that I just downloaded right off the Raspberry Pi website. It's now called Raspberry Pi OS, I guess, rather than Raspbian. I don't know. So we're going to put that in here and see if it now works. Does it go the other way? Okay. And power. Well, it's flashing this time. Hey, there's something on the screen. It's a rainbow. I hope that's what it's supposed to be. Actually, it's a gradient. I hit a key. It's still flashing, so maybe it's loading. It stopped flashing. No, it started flashing again. I have no idea how long this is supposed to take. I've never used Raspbian before. Or Raspberry Pi OS, as they style it now. I'm going to go put this away. I'll be back and see if it's booted up. So it's still flashing at me. I think it's a constant number of flashes. 1, 2, 3, 4, 5, 6, 7. Maybe this is an error code. The keyboard does not seem to be responding. Cat's back. The very next day, thought he was a goner, but he came back because he wouldn't stay away. I feel like the red light turned off. Did it? Oh, weird. Is the power maybe a little flaky? Well, I guess now I go look up and see what 7 flashes means. Well, so this is a thing that happens with Raspberry Pis. Means it can't find the kernel. I don't know if that means this kernel is not compatible with the Pi 3. Somebody was saying that it could be a matter of the power adapter, so I've plugged it into a phone power adapter for a Samsung, a recent phone, so this should give it plenty of power. And we'll see if that makes a difference. It's still saying it can't find the kernel, so I'm going to try flashing a different version of the OS on it. We'll see if that helps. Well, I don't know. Like I said, this is my first time with the Raspberry Pi, and I guess there's a learning curve. This is a different version of the OS. It's also 64-bit and supposed to have a GUI. I probably could get by without a GUI. There was one that they said didn't have a GUI. I certainly put this away too soon, eh? Okay, let's see. Does this one work? Nope, it does exactly the same thing. These were both 64-bit OSs, versions of the OS. Maybe I should try 32-bit. I understand this is supposed to run 64-bit versions, and it runs 32-bit versions much slower. I don't know. It's my first time with a Raspberry Pi. What's wrong with it? I have no clue. I have tried adding a line to the config.txt file that I was recommended to add, which is boot_delay equals 1. Let's see if that fixes it. Nope. 1, 2, 3, 4, 5, 6, 7. That suggests that it can read some files on the drive, because it would do like 3 flashes if it can't read a specific file. So this is specifically the kernel that it can't read. I'm very confused. I guess I'll try a different kernel. Okay, so trying to troubleshoot a Raspberry Pi online is hell. Nobody suggested that I could find trying a 32-bit operating system instead of a 64-bit operating system. They're like, you should check the power. You should check your SD card. It should work with a 64-bit operating system. Use the one that's recommended by the Raspberry Pi website. And that's what I was doing. It said recommended in front of it, but it doesn't work. And I tried a bunch of other 64-bit operating systems, because what were the chances that, like, they were just completely wrong about what it runs? But no, as far as I can tell, they're just completely wrong about what it runs. It does not run the 64-bit operating systems, at least not just like right off the card. Maybe if you mess with it a bit, it works, but it certainly just doesn't just work. But 32-bit operating systems do just work. So we've got one here, and we're going to try it. The first one I tried ran way too slowly. It took 5 minutes to boot up, and obviously I don't want my whole house remote to take 5 minutes to boot up. So hopefully the legacy version works better. That's the one I'm installing, the legacy 32-bit operating system from other OSs. Hey, the screen came on. Here's the screen. Hopefully it only has to do this the first time. It's the flashing. Hey, it's done with that thing and it's doing more things. It's rebooting in 5 seconds. Hey, the thing's flashing. There we go. Welcome to the Raspberry Pi desktop. Oh, and look, stuff's happening in the bottom corner there. Coin service has been started. That was much faster. Of course, I don't know if it's done. Oh, there was a cursor. There's a cursor in the corner of the screen. I missed it. That's Peanut grunting in the background. Oh, the light's still flashing. Hey, that's a much more reasonable boot up time. It's still not fast, but much more reasonable. Looks like I might need a mouse to do anything with it. Well, so my mouse got caught on a thing, and the key just came right the hell off. Great. Wonderful design for a mouse. I obviously want my mouse to look like Darth Vader. That's why I choose this mouse. We have a mouse. Hey, the mouse cursor just pissed off, but maybe that's just because I moved the mouse too far. Please stay on. Hey, now you can kind of see what's going on. Can I see what's going on? Yes, I have a mouse. There's my mouse. It's upside down to me, though. Next. Come on, stand on the goddamn button. Next. Next. Oh, I must have clicked on something. Create user. Okay, we'll just set this up. On some monitors, the desktop is larger than the screen and the edges are cut off. You can adjust this here. I mean, I don't know. It's fine here, but this may not be the only monitor I ever hook it to, for goodness sake, operating system. The operating systems and applications will now be checked and updated if necessary. This may involve a large download. I don't think I want to do that. I don't like large downloads. Your Raspberry Pi is set up and ready to go. Press restart. Okay, let's restart and launch the desktop. We're back at the Raspberry Pi desktop, powered by Raspberry Pi OS 32-bit. Things are happening again in the corner like before. So you may be wondering why I want to build a Raspberry Pi into a keyboard. So first, I don't want it to be connected to the internet because I don't want people hacking into effectively the remote control for my house. But I want to program it, so I'll need a keyboard anyway. And second, if it's going to be a remote control, it's got to have keys, and a keyboard has keys. Third, I need a case for it anyway, and why have that case be a random box when it can just be the keyboard, and I can just put other stuff in it, like batteries of some sort. Also, the keyboard could stand to be a bit heavier, you know, more substantial, like the keyboards of old. Why fill it with sand when I can fill it with a computer? It took about the same amount of time to load as before. I was hoping maybe most of that was setup time, but no. Oh, wow. That's the fancy background. Look at that. I wonder how much of the time was spent loading that background. I've got a wastebasket. Looks like if I click there, I get a terminal. What if I hit Control F1? I have a terminal! Oh my goodness, look at this. Now this is probably what would happen if I loaded it without the GUI. But I'm thinking that the GUI is going to help me program. So I'm going to leave the GUI installed. Okay, I think we have determined that it works. So now we put it in the keyboard. So we don't have to have all this stuff wiggledy-piggledy like this. And maybe we can even put batteries. I don't know. Batteries might not run this for very long. I don't really know. We're going to find out. Okay, so let's put all this somewhere else. Shut down. Now, invalid option N, sudo shutdown. Shutdown scheduled. Shutdown -C to cancel. Okay, it should shut down in like a minute or so. Let's get this mouse out of here. I guess that's going to have to be a repair video. Why? Why did you make... I mean, yeah, but why? Sarah put a piece of tape on the mouse. Hopefully that will work good for now. Okay, the Raspberry Pi has shut down. Pull the power. I can pull the keyboard. Pull the HDMI. Cool. Okay, so this is the keyboard we want to put it in. Let's take the keyboard apart. It looks like it could use some cleaning in there. Hopefully we can get at that part of it without permanently destroying the keyboard. Not this one. This one didn't come out. Come out. Come out wherever you are. See the young lady who fell from a star. She fell from a star. She fell very far. And Kansas, she says, is the name of the star. Okay, so I think probably we want to start on this side, maybe. I don't know. It's not really just coming right off. There we go. Okay. Aha. So this is the dirty part. And how do we ever get at it? We have to take every single key off? Really? The easiest part of the keyboard to get dirty, and it's the hardest to clean. Normally you would use a key puller, but can I just push them? I don't want to break them. They don't seem to push very well, do they? I don't actually have a key puller. Okay, I pushed a key. How's it look? think it looks okay. I did it once. Maybe this is not the right tool. Perhaps this tool. There we go. Well, there's something special about this key. This isn't the space bar yet, I'm pretty sure. Why did this work so well before and so horribly this time, huh? How does this work? How to remove keys without key puller? I tried to make a key puller once just by bending. Maybe we need both tools. By bending a piece of wire. I think I pulled a key with it. I'm not sure I could pull more than one key with it. Oh, come on. There we go. There just wasn't. No, we don't go. If they're all going to be this hard, what's the point? The point is that's really gross in there. That's the point. No clue. No clue why this is so hard. Just completely deformed it. And it still won't come out. Well, let's try this. Nope, that didn't work. There, finally, wow. Why were you so horrible? Oh, great. That one had a bar. Will we ever get that bar back in place? I don't know. So the shift keys have bars. These metal things that help them stay stable. So maybe we should also leave the shift keys on there. I don't know. Seems to be working. Boy, it feels horrible. Turned all the way around, didn't it? Under the stove. I had it figured out, but boy, this one don't want to go. What are the chances that it's easy now? Very, very low. Oh, maybe it is easy now. Yeah, it's easy now. So you may be asking yourself why I'm not using an Adafruit or some such. A Raspberry Pi seems like overkill for this, and I can't disagree. The problem is that I've just not found good documentation for the Adafruit or similar things. When my dad bought us an Atari computer back in the 80s, he bought a book, Your Atari Computer. I found it difficult reading as a 10-year-old. A lot of things I didn't quite understand, though I bet I could explain the whole thing over cover to cover some 35 years later. But I looked at the websites for Adafruit, where supposedly they have everything you need to know, and they're no Your Atari Computer. I mean, I can write code in C, which can be compiled. But I've only ever coded C within an operating system, ideally within IDE, or at least Simify, so when the thing crashes, you have some clue why. Is this chip running an OS? Which one? And if so, how can you say that my code is running on the bare metal? People always say, it's running on the bare metal. Is it just a crappy OS with no protected mode? Or is there actually no OS, in which case, well, I need something that will tell me more about the bare metal. Obviously, somewhere there is a thing that listens on the USB port, and if you tell it the right thing, it loads your program into memory. But is there a BIOS? If so, do you call interrupts to interface with it, like on a PC, or do you shove values into the stack and call well-known addresses, like on the Atari? If not, how do you communicate with the various I/O devices? Do you read and write memory locations, like on the Atari, or do you write and read from ports, like on a PC? Or do you use interrupts? And if it's interrupts, is there a programmable interrupt controller? How do you program it? If there isn't one, how do you even do interrupt? What even instruction set does the bare metal use? Is it big endian, little endian? Does it do floating point? I don't know, because the websites don't say. And with a display consisting of a small number of LEDs, it's going to be hell to find out. So I'm opting instead to code C in the familiar context of a Unix C operating system on a Raspberry Pi. I've never used Raspbian before, but I've used Solaris and HPUX and AX and half a dozen flavors of Linux, so I have a pretty good idea of the shape of what's between me and the bare metal. Okay. So what do you think? Does the backspace have a thingy? It's not as big. Oh, it does. Okay, so we're not going to mess with the backspace. Or I guess therefore the enter key, because it might too. This I don't think is going to. Nope, good. We've been through all these alt keys, and we know that they don't have any. On the other side at least. All right. Maybe we can just do the same with these. Or do we need to get... No, we don't even need to get in there. Could have done this all along. You may be wondering why I don't use one of the existing DIY projects out there that promise to do what I want. I considered that, but in the end, if something is controlling my house, I want to understand it better than I understand those projects. I want to understand the hardware. I want to understand the software. And if Adafruit is insufficiently documented, these projects are worse. And if they don't do what I want, I have to either convince the person who wrote it to change it, or I have to change it myself. And at that point, I'd rather be changing my own code than somebody else's code. Getting to the point where every time I put down a new key, I'm liable to knock over 3 or 4 other ones if I'm not careful. But if I don't line them up nicely, then they'll fall over and do the same thing anyway. What I'm saying is it's getting fiddly. Now, some people would clean all of these keys, but frankly the keys are not that dirty, and you can clean them when they're in place. You don't have to clean them when they're out. And that means you don't have to remember where they all were. You can just sit them out like this in order and hope the cat doesn't walk on them. As long as the cat doesn't walk on them, you're good. Well, the recording stopped. I don't know how much of it you missed. I took a keyboard apart. I started to clean it. I was using a toothbrush. The toothbrush got a lot of the gunk off, but I think maybe a paintbrush will finish this, we hope. Get into some of the smaller areas that the toothbrush didn't get into very well. It's not perfect. How much more perfect do I want it to be? That's neat looking. This. Didn't really clean it though. But it's a heck of a lot cleaner than it was. Is that a screw? That can't be a screw. This is plastic. Maybe it was a screw on the mold. Okay, so I guess we put keys back in, starting with the hard one. I want as much room as possible to get the hard one in. I think I'm going to want like something to wipe these keys on as I put them in. Yeah. Left shift key. This bar. Oh, that's not so bad. It just slides right in there. Other ones I've had, they clip in, and if you don't clip them in right, well, now the key's back in, but it's not clipped. Yeah. Okay. Let's go that way. Yeah. The Windows logo looks the same right side up as upside down. It doesn't have the little trailing bits off it on the Windows key. So how am I supposed to know which way is right side up? I guess it must be this way. I guess the other thing is all this here. Warning: to reduce risks of serious injury, read safety and comfort guide provided with product at www.hp.com/ergo. Therefore, what is this? Why doesn't it move? It moved. There's another one over here. All right, let us continue. Oh, that was a shadow. Dust moving in the breeze. Keep running into these. I better do them next before I run into them and knock them all over the place. Come on. No, that's period. That's comma. What? What? No, that's comma. What? That is a comma. Thought I had two periods there for a second. Oh, that's down. Definitely down. You may be wondering why I don't just use Alexa or Siri. I'm trying to automate my house. Why don't I just use some name brand home automation or even a discount one? And the reason is I get to find one that doesn't require me to either have a smartphone or a subscription. And there's all kinds of things I don't like about my smartphone and about the companies that would have me subscribe. But it comes down to this. I don't feel like I have enough control over my cell phone. I also don't feel like I have enough control over Amazon or Apple or China to give Amazon or Apple or China or my cell phone. Control of my house will not actually give me more control over my house. And having more control over my house is the main promise of home automation for me. I want to be able to make it do things I couldn't before. I want to be able to control more devices than I could before. I want to be able to get into the secret manufacturer menus. It's not about being to say, computer, lights on, and have the lights turn on. It's about being able to replace all of my remotes with one device and being able to program that device to do complex things. It's about taking that device to hotels and bars and using it to fix the aspect ratios on their TVs. That's what I want. And Alexa, Siri, and my cell phone are determined not to cooperate. You may think I was a bit of a sucker to pay $15 for a USB keyboard. I can assure you I bought this USB keyboard a long time ago, back when it was still not that easy to find a used USB keyboard, when most of the used keyboards around were PS2 keyboards. And I just needed another USB keyboard. I did not particularly need one with a smart card terminal. That was just a coincidence. Is that upside down? No, it can't be upside down. I don't know. Anyone else old enough to remember being annoyed that phone keypads started with 1, 2, 3 at the top and computer keypads started with 1, 2, 3 at the bottom? There's a little home key pip on 5, just like on F. Sorry, J and F, is it? Yeah? Yeah, J and F. So, the middle finger knows where to go. The problem with all these rude kids today, they don't know where the middle finger's supposed to go. So they put it all kinds of places it doesn't belong. That's obviously a joke. When I was a kid, people definitely did more than necessary with their middle fingers. Does anyone know what a smart card is? I mean, it looks like one of those things that you have on your credit card these days. But obviously this was around long before credit cards had those. What would you have used a smart card terminal with? What would you have needed a smart card in order to convince it that you're smart and you want to use the computer? So my camera keeps turning off. Apparently it doesn't like to actually record stuff to the SD card, even if I have it fully unlocked, which I thought it was just in the past it had quit because I hadn't unlocked it. I was just using the camera thing on the front. Anyway, so I have no idea how much of this you've seen, but I'm going to finish it now! And then, like, quit for the day because it's like 11 o'clock. And tomorrow I will start breaking this, now that I've cleaned it. Ah, it's just together. Oh my goodness, look at all this crud. Okay, so the other thing that I'm going to point out to this here is the actual brains of the keyboard, and it kind of sits where the card slot is. Oh, that comes off, that's nice. And so we're going to probably have to like lift it up, but as you can see here, there's this, which takes up a lot of space. So maybe we just take this out. Does it just come out? Kind of. Yeah, there it is. Cool. Now we have room to lift that up. And the LEDs will do weird things. Fun. Yeah. That's how much space we've got in there. Okay, we're back. It is the next day, and take this apart again. All of the screws and things here. Okay, so we've got a rubber dome arrangement, like so. We have a cat. The cat is checking out all the stuff that my wife has stuck to our closet where we keep all of our fermenting supplies. And he is trying to pull down the one that says, "Be ready to go north for Minnesota Interfaith Power and Light." He really wants to pull that one off, and I think he may succeed if he continues to try. He got it most of the way off just now. Maybe he just wants to sit on the keyboard parts. So here we have the circuit board, or the plastic circuit thingy, which transmits the pressure from the rubber domes to the controller, which seems to be this thing here. And of course the problem with the controller is that it is where we want to put the Raspberry Pi. But I think because we removed the little plastic thing that transmits the light from these LEDs to these holes, we can move the whole thing up. Now, these also stick up, so you might have to cut those off. But let's see. I guess technically they stick down. So, do I want to take this off? I think I want to avoid taking this off, but we need to see what's under here. So at the very least I'm going to take off and unscrew this. Ah, is there more than one screw? Hello? How are you held in place? Oh, okay. This circuit board actually goes quite a ways underneath this, so I guess we do need to take this off. So there appears to be a metal plate behind it. Yes. And it feels like there's more holding the metal plate in place yet. I don't see any screws down there. Oh no, I guess that's just the weight of the metal plate. It weighs that much. And now we can see that there is another screw here. There's a screw there as well. It looks like there might also be some kind of another contact here beyond. I don't know what this is. What is it labeled? It is a P013386A. Or maybe it's SG1. Stargate 1. There's some tape here. Aha! Maybe. Nope, I think that this screw is also holding it in place, despite being different from all the other screws. Seems to be coming up now. Yes. Okay. And underneath it is, here's the card reader thing, which is not all that thick, but I could take off if it's really getting in the way of things. But here we are. Oh, and there's more tape down here. Interesting. All right then. Here we have our Raspberry Pi. That is the exact same form factor. That is amazing. I could even potentially leave this piece of plastic in there to cover up the end of it. Wow. But, as you can see, it sits up quite a bit. That screw lines up with that screw hole though. Look at that. They just line right up. The other ones don't. That one does. Wow. Okay, so if we were to line that up like that, you can see that we want to cut some holes in this piece of plastic so that the ports can stick through underneath. I don't think they will stick through too far. So yeah, that's what we want to do, and then maybe we want to put this piece of tape. Where the heck did it go? Now it's stuck to everything. No, that was this piece of tape. If we put this piece of tape in between like so, then that will protect most of these from contacting anything on this. Yeah. I might just want a little piece of tape there and a piece of tape there. That's like excellent, really. Okay. Well, it's time to try and somehow mark where we want things to go. Also, I think I'm going to unplug this. The red one is on the right. There we go. So hopefully we can keep it out of the way. It really kind of wants to be in the way. These all ports face the back, so that's good. We make holes for them. Oh, here we go. Now I can move this over here. Yeah. So that is, yeah, that's equal distance from those things. So if it's in the middle, it ought to be fine. Yeah, like that. So now we make marks. You'll be able to see marks that I make with this. Okay, now I have to decide what I'm going to cut it with. No idea if this is going to work, but if it does, it'll be very fast. Oh, hello, cat. Okay, the cat has left us. Well, it worked. It also cracked it a bit. Yeah, I think I need to be doing them not the whole length, because they crack further than I want the cut to go. Yeah. If only the cracks were straight. Oh, that's pretty messy. It's brittle. Well, that was very fast. So maybe it's worth it. Everything is probably not going to line up perfectly, though. Yeah, everything is kind of bent that way. Let's see if we can fix that. It's better. Straighter. I bet this is out of frame. Nope. Yeah. That was the case on the old case anyway, so. It is so close, but this just sticks out a little too far, doesn't it? So I guess we've just got to take it off. Okay, and that is just too wide as well. I'm going to say that probably sticks out further than we want. Also, so we have another problem, which is that stuff sticks out the bottom further than I thought it was going to. Like, I'm going to want to use these GPIO pins, and they're right up against the case. But at the same time, like this, it's pretty nice. This foot doesn't get in the way, does it? No, not really. Foot does nothing. this is getting in the way. So I need to trim that all off a little bit more. I can't use that for that. Well, maybe I can here. It's not going to be straight, though. And the whole thing came off. It might actually be straight at that angle. Pretty close. Well, there's this. This is in the way. That's in the way. That's what's in the way of the GPI opens. Okay, so these old screw holes need to go. And it shouldn't matter that this isn't screwed in place anymore because we're not using the card reader, which is the only thing that needs to be in a specific position. Yeah. Could I just cut these off with this same thing? Wouldn't that be nice? Yes. Yeah, they're not really all the way cut off though. Maybe I need to file them down. I borrowed one of Sarah's metal files here. Yeah, that gets in there quite well. Almost flat. Very nice. Somehow, it just isn't easy to do unless I do it off camera. No idea why. Okay. Nice. Maybe get a little bit more off that one. Alright. Let's clean this off. Wow. That's just like kind of perfect. That's not great, but I suppose I could smooth that out with the file. Isn't that a lovely noise? It's better. So now, this should fit in much better. And it does. Mostly. I think this is still too long because that's, oh no, it's this now that's too long. Okay. Here we go again. Rag to my brow. Say hello to Brow Rag. So I think that's probably still not quite good enough. Thank you, Cat. Am I cutting the wrong one? I'm cutting the wrong one. It's the one at the top. Well, at least that one ought to be easier to cut. I think that lines up now. It's a mess on the bottom, but it lines up. It is just a little close though. Where is it binding now? Right there, that corner. Okay. I can do something about that. Maybe this is too close. I think I can probably get the whole thing flatter this way. Maybe this will do a straighter line if I want to do this a little bit more. It's hard to get at. Yeah, nope, not anymore. Can't get far enough in with that. Well, there we go. That's good. Sure. How's it look now? So if I want it to be straight, I feel like this has got to come off too. Because notice I want it to be in between these two things here nicely, and this is in the way. There we go. Yeah, that looks very good. Cut too much off of this, but I think we're good. Okay, so now I need some kind of a bushing in there so that that screw can go in. Let's get all this plastic out of here. Now, assuming these aren't too thick, maybe 2 of them won't be too much. Holding all this in place is going to be fun. Okay. Screwdriver. Oh, maybe they are too big. They just went right off to the side immediately. Still going up. Let's try putting another one in. At some point the screw is no longer going to catch. And if we get to that point, we've got trouble. Though I do have a lot of screws. But will I have one that fits? I don't know. The screw is not catching anymore. I mean, I guess maybe it's in. Are we good enough? Are we in? It's still running into something there. What is it running into? I don't know how much you missed. My phone keeps just stopping recording for no apparent reason. I need a longer screw. This one might be too long. That is excellent. Yeah, that's very good. So, now I need to drill some new screw holes for the other holes in the board. And we need to drill holes for the input ports. But I think we need to get at least 2 screws in first, because otherwise the position of the ports might drift a little bit. Yeah. Cool. That one might be just a little too chunky. Let's see here. Maybe it's fine. Not, I don't think it's actually going through the hole that I drilled. Maybe it is. Is that actually where I drilled the hole? This is the point where you're supposed to start going through the bottom of the keyboard. Are you going through? Yes, you are. There we go. The screw is a bit too long and it will stick out the bottom. I might have to cut it off or something. There we go. Ta-da! I think we're going to have to use the feet from now on. But, yeah. I like it. So the screw sticks way out. See if I can find a shorter screw. Also, now that I've made a hole in the back, I could potentially use a threaded screw, threaded standoff, which I do have many of. So maybe I'll go look at my standoffs. I have a feeling that my standoffs are too tall. But we'll see here. I kind of assumed that that hole would be big enough for one of these now, but it isn't. So I guess we do want a screw. This screw looks shorter. Ooh, it's big though. I think it's just too big. Let's try this one. Okay, that's not too bad. It's not long enough. It just does not go. So we've got one screw that's too long and one that's not long enough. This one's a little longer and it's not pointy on the end. It's a bit bigger though. Not being pointy on the end, it might not go through the hole. Oh, it does. There we go. Oh, perfect. Okay, cool. So now it's being held in place well enough that we can mark out where the ports, we're going to drill holes for the ports. Okay. Let's see if I can see that now. Yes, I can. All right. Now I know where to drill the holes. Let's take the pie out so I don't drill the pie. You know, it might have actually been the output ports that were in the way earlier. If I had just drilled the holes beforehand, everything would have not lined up, so I couldn't have done that. But if I had, then maybe it would be a little more square now. Okay. That's where we drill the holes, and as close to the top as possible, I think. Alrighty. This is a drill bit for a bigger hole. I have to wander around for there we go. These little strands of plastic all over my electronics. Fortunately, plastic is pretty neutral, isn't it? I don't think it does much. Let's see if we can use these cutters to widen these holes. Probably not. Ooh, maybe. Doesn't look like it. So we're back with the drill. Almost. There we go. I think there's probably a 0% chance that that's big enough for an HDMI cable. Suppose we can test it. Nope. This is probably too big, but I'm missing all the drill bits in between. I've got too many projects on the go. Okay. How does that line up? Surprisingly well. The HDMI cable is going to be the problem. Where did I put it? I just had it. Is that you? Yes. Of course, this screw is still here, so it's actually holding it away from the board. Okay, how does it line up now? Oh, much better. It's maybe not quite wide enough, but almost get it in there. That seems to line up too. I think we're very good, actually. So we just need a little more on that side. Yeah. Do you go in now? Yeah, it kind of does. Does it go in without this? Yeah, it does. Yeah. I think we're good. I feel like there's not much leeway though. So let's route it out a little bit more. Yeah. Am I confident enough to just screw it together? Probably shouldn't be. There it is. Everything seems to line up. This is kind of running into that there. That is unfortunate. I bet that is not going in far enough to actually make a connection. It's barely going in at all. So I need to cut away that lip there. I think that means taking the pie back out. I think that's going to work. Maybe from this side. Oh, the file will fit through there. Hell yeah. Okay, how does it go in now? Oh, much further. Yeah. Still feels like it's running into the lip a bit. We've got a file now, so maybe we can fix that. Alright, that has removed quite a bit of it. Now we have a little pile of carbon black. Probably isn't really that. A little pile of black plastic. Okay, I think we're good here. All right. It is tightly in there. Excellent. Let's try one last time. Plug in an HDMI. It really doesn't go very far in, does it? That isn't wide enough. Our file is not as wide as an HDMI port, it turns out. No, it's not getting past it. It should be. Shouldn't be able to see it at all there, and you can still see it. How can I grind away more of that? Well, actually, I'm not touching the board if I do it from here, so I can use the drill. Yeah. Nope, not far enough. Gotta go further. How much of it do I have to eat away? Where is it running into it now? Everywhere still? Is it still running into it everywhere? It's on this side. Okay. Oh my goodness, I think it went in. Yes, it went in! Alright then, that's as far as it's going to go, unless we take even a bigger chunk of it out. So let's hope that's far enough. I'm going to put it back together. Next thing is this. This is going to go on top of it now. Now we have a problem, which is that there are keys there, aren't there? Yeah, there are keys there. How do we fix that? It's lined up right, but it's almost certainly showing contacts on the Pi. And we have those keys there. I mean, it's almost in place. So let's put that tape on. Okay, we need just a little extra tape there. that. Well, so what I have found is another keyboard that looks the same except it doesn't have that thing here. And if it's the same inside but doesn't use this, has a smaller board because it doesn't do all this stuff, then maybe that'll fix my problem. Ha 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 ha. So let's take this back out of here. These are the same as the ones in the other. Basically, yeah. I think there are going to be screws under these feet. Would you build a keyboard without a screw in the corner? Yeah, no, you wouldn't. Neither would I. Of course, I haven't tested this keyboard, so for all I know, this keyboard doesn't work. Yep. Screws under feet. Who would ever have thought that there would be screws in the corner of a keyboard? I better hide them so nobody knows. Did I actually unscrew one of these? Like this one maybe? Yeah. Okay, I got that one out. Oop. Ah, and this one here. Did I do something wrong? Those two screws came out. Yeah, I don't know. There we go. And indeed it has a smaller board that would fit right there. Hurrah! Alright, here's what we're going to try. I have some screws. I have the thing to use as a spacer, which is like a piece of coaxial cable, which I have so much of because, well, that's a long story. And I'm going to try and use this to space these things so that it goes in the thing and it connects, and then I have a keyboard. That's what I'm trying to do. I guess I'm going to check the camera every 5 minutes or maybe 2 minutes to make sure it hasn't shut off. Okay, that seems to line up pretty well. Oh, I was going to pull the... No, it's not too late. Oh, Peanut has to check it out. There we go. Now there's room in the middle for the screw to go through. Hi, Peanut again. You come to sit on the corner of the table like a raven. Alright, where did the other one go? Who knows? Those are the same size, we will use them. no idea how I'm going to hold all this stuff. I suppose I could put the screw into this first. Maybe that will help. I don't know. Yeah. Probably actually need to, now that I think of it, because nothing will stop this from just spinning in place otherwise. There we go. Maybe I need to make a hole in this first with a sharper screw. Okay, now there's a hole in it. Maybe this will go in. The part where the screw actually goes further in as you turn it. There we go. Wow, it just barely sticks out. That could be a problem. Okay. And now it no longer fits. No, come on. It's gotta fit. There we go. Hey, it's through the thing. This is a lot easier. Oh, wait a minute. No, I think that's right. It's weird that matches the thing below it, but I'm pretty sure that this is the way I saw it before. Yeah, okay. So now this goes through here. I think. It tries to go through there. Maybe we should do this the other way around. It is, I believe, reversible. Oh, much better. Okay, and then this. No. This goes through there. Nope, it doesn't. This goes through there. This goes through there. And then this goes on top. And then we turn the screws. Maybe. And we line the screws up and then we turn the screws. I'm not sure the screw went through. That screw went through. This screw still needs to go through. Wait a minute. These screws were tight before, and now they're just coming out. What happened? How did you get screwed up, you screws? Apparently if I screw it into the meat of my hand, maybe then it works. Well, this screw is now in. This screw is definitely not in. There, now both screws are through. And of course it's diagonal. Of course it is. Is it still diagonal? I don't think so. Okay, now maybe we have a chance. Maybe we screwed it up. We're about to find out. It still seems a little off, but what can you do? Hopefully it'll be close enough to on. And now we put this back on. It doesn't want to go. Probably because things stick out. So I guess we have to cut off some of the things that stick out. What is running into what? Oh, maybe it's not quite lined up. Okay, that side is lined up, so now we know this side better be. It doesn't want to go. And that is actually pretty close. And this side goes in. This side goes in, basically. Okay, cool. And you can see it's a little thick there, but we've got lots of screws to put in that should hold it in place. All right, let's put those screws in. Oh wow, that snapped into place. Amazing. I would never have thought it would. Looks like this one might have had feet too at some point, but they're gone now. Let's see if they stay. Probably they won't. Because dust and tiny pieces of plastic. Okay. There it is. It's a little thick on this end. And it needs the feet to be level. Does it work? Plug it into itself. Somehow that mounts down one of the feet. Okay. Plug in the HDMI. Hopefully it goes in far enough. Seems to be as far in as it's going to go. And we plug in the power connector, which hopefully also fits. It requires a little less leeway. So fingers crossed it just works. Doesn't seem to work. Maybe that's upside down. I have to take it apart to be sure. I do not know. Okay, that's not actually connected. Well, I guess we get the drill out again. Still can't get at it. Aha! I can see it better now. Maybe I can plug into it now. More of that. I see no lights. It really looks like it ought to work. The lights flashed on this side before, did they, or did they flash on the other side? Maybe they always flashed on the other side. Well, who knows. Let's see if the keyboard still works anyway. Oh my god, the keyboard works! So it's just this plugs here, or I've messed it up somehow. So I guess I just need to, like, cut away a lot more of the plastic here. Somehow. So what is in the way? That part there is in the way. Okay. I get rid of that part in any way, shape, or form with any of these things that I have at my disposal. Okay, that is definitely plugged in now. Is it plugged in on the other side? I mean, what the hell? It's definitely plugged in on the other side. Don't go into the port. Don't screw up the port, please. I don't have a way to get another port on here if I screw up the port. Okay. No. Why? Why do you only drop the plastic into the port? Why not anywhere else in this room? Okay. Does it go further in now? Where does it bind? That seems to be all the way in. Like, I can't get it any further in than that. You plug the keyboard into itself. That's the way we roll. And then power. Oh my God! The monitor's on. There's a flashing cursor in the corner. I don't know if you can see it from here. There we go! Welcome to the Raspberry Pi desktop! I hit numlock. A light barely comes on. Let me turn the light so you can see it. Yes, a very, very dim light. When I hit numlock, caps lock does not work. That's weird. But numlock does. Yay! Oh, now caps lock works. Okay, and now we're in the GUI. Okay, but let's, I want to test the keyboard. So Control Alt F1. Hey, we're at a terminal. Yes. The quick brown fox jumps over the lazy dog. The keyboard works! And the Pi works! The Pi is in the keyboard and they both work! That's the end of part 1.